Hello friends, in this video lecture, we will see round robin scheduling algorithm with example. Round robin scheduling algorithm is similar to first come first serve scheduling algorithm, but here in this round robin scheduling algorithm, preemption is added to enable the system to switch between different processes. It is preemptive scheduling algorithm. As I told you in the first statement, that preemption is added to enable the system to switch between processes. A small unit of time called quantum, that is time quantum or time slice, is defined. A time quantum is generally ranges from 10 to 100 milliseconds in length. To implement a round robin scheduling algorithm, we keep the ready queue as FIFO queue of process. Means to implement this round robin scheduling algorithm, we have to follow the same strategy we have followed in the first come first serve scheduling algorithm, which is operated on the basis of first come first out queue. Round robin scheduling algorithm is designed especially for time sharing systems. The process having CPU burst time of less than one time quantum will itself release the CPU voluntarily if time quantum is 1, and scheduler will then proceed to the next process in the ready queue. In the implementation of a round robin scheduling algorithm, no process is allocated the CPU for more than one time quantum in a row. If a process CPU burst exceeds one time quantum, the process is preempted and is put back in the ready queue. Performance of round robin scheduling algorithm depends heavily on the size of the time quantum, that is time slice. And in round robin scheduling algorithm, context switching is used to save the states of preempted processes. Now let's understand this round robin scheduling algorithm with the help of problem. We have some set of processes, that is P0, P1, P2, P3, with given arrival time and CPU burst time. We have to compute average turnaround time and average waiting time under round robin scheduling algorithm, and we have to take time quantum, that is time slice of 3 unit, which is given there in the problem. We have to follow the same strategy as we have followed in the previous problems. To compute waiting time, we have to compute turnaround time. Means with the help of turnaround time and burst time, we can calculate waiting time, and turnaround time is calculated with the help of completion time and arrival time. Arrival time is also given there in the problem. We have to calculate completion time, and in problem time quantum of 3 is given. Now let's sketch the NAT chart first. We start from 0 in the ready queue. At 0, we are having only one process, that is P0. So CPU will be assigned to process P0. In ready queue, at 1, there is arrival of another process, that is P1, but here process P0 is allowed to execute for time quantum 3, means process P0 will not be preempted. At 2 at head of the ready queue there is process P1 followed by another process, that is P2. Means at 2 ready queue looks like this. This is head of the ready queue and this is tail of the ready queue. Means after preemption of the running process, CPU will be given to process P1, but because of time quantum, P1 has to wait for the completion of process P0 for time quantum of 3 units. At 3 there is arrival of another process P3. Means ready queue is having 3 processes. This is head of the ready queue and this is tail of the ready queue. So at 3 there is a preemption of process P0. P0 will be preempted and CPU will be given to the next process in the ready queue, that is P1. P1 will execute for how much time? Time quantum of 3, means total time will be 6, and process P0 which is preempted will be put back in the ready queue. Means ready queue will be like this. This is head and this one is tail of the ready queue at 6. So at 6 CPU will be given to next process in the ready queue, that is P2. P2 will execute for 3 units, total is 9, and at 9 ready queue will be like this, and preempted process P2 will be put back in the ready queue. Means after preemption of P2, CPU will be assigned to process P3. P3 will hold CPU for 3 units. Total time is 12. Then after P3, CPU will be assigned to next process, that is P0. For how much time? For 1 only, because the remaining time of process P0 is 1, which is lesser than the given time quantum. Then after preemption of P0, here at 13, P0 will preempt the CPU voluntarily and CPU will be assigned to next process, that is P2. For how much time? 3. Total is 16. After P2, CPU will be assigned to next process in the queue, that is P3. For how much time? 3. Total is 19. And after execution of P3, CPU will be assigned to next process in the queue, that is P2. So P2 will be executed at 20. So completion time of process P0 is 13. Completion time of process P1 is 6. Completion time of process P2 is 20. Completion time of process P3 is 19. Now turnaround time is completion time minus arrival time. So for P0, turnaround time is 13 minus 0, that is 13. For P1, turnaround time is 6 minus 1, that is 5. For P2, turnaround time is 20 minus 2, that is 18. And for P3, turnaround time is 19 minus 3, that is 16. So average turnaround time equals to total turnaround time, that is 52 divided by number of processes, that is 4, equals to 13. And waiting time for P0 is turnaround time minus burst time, that is 13 minus 4, 9, 5 minus 3, 2, 18 minus 7, that is 11, and 16 minus 6, that is 10. So average waiting time is total waiting time, that is 32 divided by number of processes, that is 4, equals to 8. For more such videos, stay connected, and thank you for watching.